All right, remember, we're still in this derivation where eventually we're going to know what u1 and u2 are. And for right now, I'm telling you that thinking about how we solve this type of thing is important, but remembering the details of this particular thing is not important. So continue with not taking notes if that's what's comfortable for you. I'll tell you when to start taking notes again. We had gotten to this equation right here, where I had rearranged the u1 and u2 terms by themselves for some reason. And the reason is because this term right here, y1 double prime plus p times y1 prime plus q times y1, hopefully you remember from here. If y1 and y2 are solutions to y double prime plus py prime plus qy equal to 0, that means that when I write them right here, I should get that those terms go away. So this should be equal to 0, and this should be equal to 0. So those u1, u2 terms drop out. So now I'm left with all the leftover terms that had u1 double prime, u1 prime, u2 double prime, u2 prime. This is kind of similar again to when we were working on reduction of order. Remember, we tried to get rid of the lowest order terms because there were too many derivatives for us to deal with. So now I've taken something with u, its first derivative, and its second derivative, and we just have the second and first derivative of u. Still not great. On this slide, I've gone ahead and copied that equation, taking out the 0 terms. So just this part right here, I've copied down because I didn't want to make you watch me write another thing if I could avoid it. And I've just written that explanation we just talked through. Since y1, y2 satisfy the differential equation, those first two terms went to 0, and all we have are the leftovers. We're still trying to figure out what u1 and u2 are. So we're going to do some more backwards calculus and algebra manipulation to kind of try and simplify this even more. So I'm going to leave the p term by itself. That's actually where I'd like to see it. And what I'd like to do is try and get rid of these second derivatives because they're the thing that's still bothering me here. And so I'm going to go ahead and say, well, if I had a derivative of u1 prime y1, then that would account for my u1 double prime y1. But it would also have a spare term u1 prime y1 prime, just by the product rule. But if I added another one of these u1 prime y1 primes, then that would be plus 2 u1 prime y1 prime, which is exactly what I had above. So just to recap, what I've done is I've taken this second order term and I went ahead and put it inside of a derivative so that I would be looking at first order terms. And one of these first order terms is also inside that derivative. And I just have to sort of bookkeeping wise hold on to the extra right there. And I can go ahead and do the same for my u2s. So u2 prime y2 plus u2 prime y2 prime. So I've got my p times u1 prime y1 plus u2 prime y2. And then I'm going to bring my derivative terms together. So the derivative of a plus b is the same as the derivative of a plus the derivative of b. So I can just bring all those things together here. So now what I have is an equation where I would know what p is, I would know what y1, y2 are, and I would know what f is. And then all I have is kind of a differential equation for u1 prime. And what I'd like to be able to, u1 prime and u2 prime. What I'd like to be able to do is find a way to solve for u1 and u2. And so this equation is satisfied if I have the following. So if I go ahead and say that f should be equal to u1 prime y1 prime plus u2 prime y2 prime. So I've gone ahead and represented that thing right there, then what I would have to have is that these leftover terms right here should be equal to 0. So let's call like the assumption that f is that thing star, and we'll say the assumption that this thing right there is equal to 0 is like a little leaf, I guess. If I want those two terms to both be 0, p times u1 prime y1 plus u2 prime y2, and the derivative of u1 prime y1 plus u2 prime y2, that could be accomplished by just saying that I should have 0 equal to u1 prime y1 plus u2 prime y2. Then 0 times p would be 0, and the derivative of 0 would still be 0. So these two equations have gone ahead and met all the conditions of the single equation above. And this can seem kind of arbitrary. But remember, it's okay that it's arbitrary because all I want are conditions that tell me what u1, u2 have to be for y sub p to be my particular solution. So it doesn't matter that these two equations I kind of invented as a way to satisfy the equation above. The equation above makes it so the y sub p is the solution to the differential equation. So these two random conditions, as long as they make that happen, it's okay. And what's fortunate for me is that this is two equations for two unknown things, u1 and u2, specifically for their derivatives, u1 prime, u2 prime. And since y1, y2, and f are all known quantities that are functions of x, I could go ahead and plug everything in now, and I just have an algebraic problem. Solve for what u1 prime is, solve for what u2 prime is. The only thing is that that would be kind of a difficult set of equations to solve. So this is two algebraic equations for u1 prime, u2 prime, which are my two unknowns. And it's just going to be easier to solve using determinants. Oops. Those are the tools that we got some practice with when we were determining that things are linearly independent to form fundamental solution sets. So hopefully you remember. We're going to bring back our Wronskian equal to y1, y2 on the top row and their derivatives on the bottom row. And then we're going to invent two different determinants. We're going to have w1 is a determinant where we sort of hold on to y2 and y2 prime, but then where the y1s were before, we replace with 0 and f. And w2 is going to be, we hold on to y1 and y1 prime and replace the y2 column with 0 and f. And just to be clear, w, when we compute our determinant, is the main diagonal minus the off diagonal products. So we're going to have y1, y2 prime minus y1 prime, y2. w1 is going to be 0 on the main diagonal minus f times y2. And w2 is going to be y1f on the main diagonal minus 0. So using that notation, the solutions will be given by u1 prime is equal to w1 over w, which is just going to be minus y2f over y1, y2 prime minus y1 prime, y2. And u2 prime is equal to w2 over w, which is going to be y1f over y1, y2 prime minus y1 prime, y2. And so real quick, I'm just going to sort of point out to you, oh no, I'm not, I'm at 10 and a half minutes. Okay, stop here. Next video, you're going to start taking notes again.